When you could do substitution on this one, you could solve for x. What works more often is, well, the substitution method comes in handy. We had to use that for parametric equations, getting rid of the t. But we do need to know how to use elimination. And the elimination method would say, yeah, exactly. So multiply this by -3. This first one. I'll get -3x minus 9y equals -21. And now those x's will cancel. So it's elimination method is a very direct way of doing things, of getting rid of variables. The whole problem with either one of these is that there are too many variables in each one. There are 2 unknowns in each one. There's no way to solve. But if I'm given 2 pieces of information, I should be able to figure that out. I should be able to figure out the 2 of them. Unless that second piece of information is something that doesn't help me. So for example, if I said I am twice as old as you are, and then I said you're half as old as I am, I haven't told you anything new. I just told you the same damn thing. Right? It's like, thanks, Jeff. So there's 2 things I don't know, either one of our ages. But there's not 2 pieces of information. They gave the same piece of information twice. Here, these are actually 2 separate pieces of information. One does not depend on the other one. So when I do this, the x's go away. Divide by -14. Y is 2. And then I can solve for x pretty quickly. If I plug a 2 in there, subtract the 6x is 1. I can write the answer as a point, because what's really going on graphically behind the scenes? What does that answer truly refer to with these 2 equations? Yeah, if I graph them, that's going to be where they meet. Cool. On number 2, I would definitely use substitution method, because y is that. So I can rewrite the second equation using that information. Y is this. So why write y when I can write that? And now I've got 1 variable in there. I can solve for that 1 variable. First off, this goes away. X minus 2x plus 8. Negative x equals -7, so x is 7. Is that cool? I mean, this is the stuff you can really sink your teeth into. This is just attack it. These are called systems of linear equations, of course. Here, y would be 7 minus 4 divided by 3, so y is 1. So if you graph those 2, it would meet at the point 7,1. Yes, ma'am?
For that one, since you're going from 6y, can you say like 3y equals x minus 4? So 6y would be 2.
Yeah, sure, you can do that. I love it. You're a little teared by eye, because if you want to replace y, you can actually consider it as, I want to replace 6y. Not a damn thing wrong with it. So you can say this is 3y equals x minus 4, so 6y must be 2x minus 8. Right?
2x minus 4, because it would be minus 2x minus 4, so it's still be plus 8.
And now if you want to plug it in here, x minus 6y, 6y is 2x minus 8. And now the negative comes through. Do you guys see that? So if I had, for example, and it happens actually pretty often. Well, let's see if I can make it work. That would be nice. Yeah, that's all right. That's easy. Yeah, this happens. So instead of solving for x and bringing in all this extra crappy fractions that we should all be able to handle, but it's just one more place I can make a simple mistake. So why deal with fractions if you don't have to? You can take this first equation and double it so that it matches what this guy needs. So this would be 10x equals 14y minus 4, and then you can just plug that in there. I love it. So when you, that's sort of like what I was talking about earlier, when you try to eliminate the t parameter. from a set of parametric equations. You don't have to solve for t all the time. You can be smart and stop somewhere. You can, if I have a t squared somewhere else, I can stop at t squared. I don't have to make it plus or minus square root. So this is really what's going on. I don't have to solve for x. What I really want to do is replace 10x. Okay, cool. I can replace 10x. So then y plus 10x, which is this. So 15y minus, what is that trying to say? 4. 11, y equals 1. X would then be 1. Is that cool? So again, very often it's you learn the basic procedure for something, but then you play around with it enough that you realize there are alternate ways of doing the same thing that just are easier to look at, or sometimes quicker to actually do. Okay. So you see a bunch of substitution methods, you'll see a bunch of elimination methods. Now let me give you one to really try here. I'm trying to make it work at the same time. This could always do it. We'll make sure it'll actually work. Oh yeah. Well, again, those of you who know how to plug matrices into your calculator, that's awesome. Do this by hand. Why? Because I'm evil.
You're old school.
Totally. It's even more than that, though. I mean, when we have new technology come out, we now have Wolfram Alpha that's out. I think have I talked about that in this class so much? Yeah. And that's just silly. I mean, it can do so much shit. But does that mean we suddenly want to stop knowing how to do things by hand? No, of course not. Because the more you know how to do by hand, the more connections you can make with later stuff. The more you leave the technology to do for you, you have nothing to make connections to later. You'll sink and burn in whatever highest math course you got to take because you can't make the connections. Yeah. Good. I love it. So if you're really not sure what to do with this, maybe just sit there and stare at the wall, but most of you should have seen this before this class. If it's been a while, maybe you forgot how to do it. Try to dredge up something out of the old memory banks. If you heard what she just said, that's exactly the way you want to go. Maybe work with 2 equations first. So as you guys are working that out, if I solve a system of equations like the one we had earlier, if I solve this system of equations, what does that really mean graphically again?
Intersection.
Yeah, the intersection of these 2 lines. There's these 2 lines and where they intersect. This is a line. This is a point, right? That would be a point at 7. Yay. This is a line, 2-dimensional line. And if I take one more step up to three variables, what's the next kind of step up in terms of geometry? Point, line, plane. Right, the basic building blocks. So points, you put them together, that builds into lines. If you put a bunch of lines together, you build a plane, right? So these are 3 planes. So for example, it could be the plane of this wall, the plane of that wall, and the plane of the ceiling. Where would the solution to that equation be? Yeah, that corner point. Now, do they always, like 2 lines, do they always have to meet? No, they could be parallel. Poor little dudes. Or they could be, think what you would, they could be right on top of each other. So the answer would be all the points on that line. Planes could be parallel. Now you got 3 freaking planes. So you could have 2 planes there and 1 plane connecting, through both of them. But there's no point that they all come to. So there's actually a lot more ways that 3 equations could lead to infinite solutions, possibly no solution. This one leads to 1 solution, should be. So let me catch up to you guys a little bit. What variable did you kill first? All right, so you could either do x or y, right? So I think I heard a few more y's. Let's look at that real quick. One way to kill the y is to do 1 plus 2. And I want to ask you, obviously you're cool with this, because we just did it a minute ago. But why am I allowed to do this? Why am I allowed to do this? What did I just added 2 equations. Why exactly am I allowed to do that? Right, we just added those equations together, straight up. This side, that side. Why am I allowed to do that? On one level, if you're not sure about the answer, it should bug you. Why the hell can you do that, dude? What the hell? Does somebody understand why you're allowed to do that? What did I add to this side? 2. Whatever you add to one side, you're supposed to add to the other freaking side, Jeff. But you added x minus y. But what is x minus y? 2. So of course I added the same thing to both sides. That's why I'm allowed to add 2 equations. If I add 2 to this side, I better add to the other side, right? Good old, whatever you do to one side, you got to do the other side. But x minus y is 2. So if I add 2 to this side, I can add x minus y to this side. That's why I'm allowed to do this.
2 equivalent? Yes, like x minus y is a 2 equivalent.
It's the equivalent of 2. I love it. So wherever you do 2 to something in this setup, you can do x minus y to the other side. Cool. Maybe. So that's why I'm allowed to do equation 1 plus equation 2. And what do I get when I add those together? 4x. The y's go away, plus z equals 8. And I'm going to call that equation 4, crazy enough. The biggest problem people have with these is bookkeeping. What the hell is where? That's where matrices really come in and help us out a lot. Matrices are sort of like synthetic division. They kind of focus on just the numbers instead of all the x and y's and z's. Who really cares about those? We just care about the coefficients, really. Right? Why is this one? Why is the coefficient of y so cool here? Because it's 0. It's gone. That means it's dead. So a matrix have a 0 sitting somewhere. We know that variable is gone. Right. What else can I do here to kill y again?
The opposite or something?
I can't use 1 and 2 again. The smart thing to do is to use 1 and 3. Why do I say that? Because it's already opposite signs. I just have to do what here? Yeah, double it, right? So you do twice 1. Twice 1 plus 3. So twice 1 is 2x minus 2y plus 4z. 12 and 3, leave that dude alone. Yep, so now I get x, these go away, plus 8z equals 33. And crazy enough, that's number 5 equation. Yes, sir? Because, for example, right here, what did I add to this side? What did I add to the 12? I added 21, right? To get 33? You with me? And I can do that as long as I add 21 to the other side. But isn't 21 equal to this? So isn't adding this to this side equivalent to adding 21 to this side? Because they're the same damn thing. You with me? If I add 5 to one side, can I add 2 plus 3 to the other side? Of course I can, because they're the same damn thing. But isn't 21 equal to this? So if I add 21 to this side, I better add 21 to that side, and I did. Because that is 21. So thank God, logically it works, because you desperately want to be able to do that. Right? Because, you know, like those y's want to cancel. If only I can add them. And yes, you can, because it actually falls into the rules. Now what the hell do I do? Why did I kill the y's twice? Because you just don't like the letter y? Because now between 4 and 5 I have the same variables I can do just like we did earlier. I could do substitution method or elimination method, whatever the hell you want to. So if I take this one down and multiply by -8, maybe? We have negative 32x minus 8z, negative 64. So we get negative 31x equals negative 31. That's nice. So an x is 1. Now you take one step back. Now it's like dominoes. They start to fall back. You get 1, it falls back to here, you get the other one. You get 2, it falls back to there, you get the third guy. Dominoes, it falls back through what you did. So up here, I know x is 1. So 4 times 1 plus z equals 8. So z equals 4. Is that cool? Wants to know one variable, I can plug its value in wherever the hell I want to. So I'm going to plug it in here, of course, so I can figure out what z is. Now that I know x and z, I can plug it in over here and figure out what y is. So 3 times 1 plus y minus z is 4. So I get 3 minus 4 is negative 1. Add it over there, I get y is 3.
So x or z equals x minus 8?
Well, just 4x plus z is 8. So plug a 1 in for x and solve for z. So just subtract the 4 over.
No, right here next to the number 4, you put x minus 8. What is that?
Oh.
What do you mean by that?
I'm going back to old school times.
Oh.
So I'm saying, I'm telling myself what the hell I'm doing, which is an excellent idea. Both for you, so that if you stop in the middle of a problem and you get up and you go somewhere and you come back and you're like, what the hell did I do? You can see what you did. And for me, if you make a mistake, if I can see what you were trying to do, I can tell if you're on the right track or not. If that's not there, I don't know what you're trying to do. If you multiply something wrong, I'm like, shit, what were they trying to do? Yeah. So it's really a good idea to tell yourself and me what the heck is going on.
So what is going on there?
So I multiply that by -8. Why did I do such craziness? Because I was kind of lazy. I wanted to bring him down, and to make that z match with that z, I have to make it -8. So it would cancel. Cool. I could have multiplied this guy by -4, but then I would have had to rewrite both of them. I was lazy.
You're just attacking each variable one by one, and so you can...
Exactly. So you can imagine, and this is very possible, I could have 5 equations with 5 variables in them. Right? You pick a pair of them, you kill a variable. You pick another pair of them, you kill a variable. You pick another pair of them, you kill a variable. Pick another pair of them, and now you got 4 equations with 4 numbers. And then you do it again. That's where, my God, please realize I am never going to make you do that. Once you get the pattern down, it's the same pattern, so it's like busy work. And I would not blame you, say, this is busy work, screw you. And I've done that to my teachers in the past. Because that's what it is. This is busy work. Leave me alone. Teach me something new. That's where matrices really come to handy. Matrices, I don't care how big you make the problem, the process is about the same amount. It's just a little bit longer. If you add one more equation on here, good God, this becomes long. Because if I had one more equation on here with one more variable, maybe a w, I'd have to pick a couple, just to get a system of 3 with 3. And then I have to do this whole thing we just did again. There'd be so many levels to that. You guys kind of see what I'm saying? So writing it in terms of matrices, if I add an equation, the amount of extra work does not increase that much at all. If you've done matrices before, you might know what I'm talking about. But if you haven't, you will very soon. So what at the end, what do I write here? Beautiful. Alphabetical order. 1, 3, 4. Cool. So these planes, however they're situated, these planes intersect. And there's a third one. I don't have 3 ends. They intersect at that one point. 1, 3, 4. Here's a cool one. I want you guys try this one. And up front, I'm going to tell you there's a weirdness to it. Very first thing, are any of these equations not in what I would call lowest terms, reduced form? Is there something you can do with one of these? Yes, then you do it, obviously, right? If the more ones you have, the more one coefficients, the easier this whole process is, of course. Because then you can triple it, make it a 3. You can do whatever you want to with a 1. So it's not a bad idea to just take a second and rewrite 3. This is a stupid way to have it, so let's make it that's much better. We can make a letter Z. Exactly, cool. me catch up to you guys a little bit here. What letter are you going for first? So a few people going for X, a few people going for Y. Personally, I would go for Y just because there's already one that's a different sign. Because again, I mean, we certainly shouldn't make a lot of these mistakes, but anytime I have to do something with a negative throughout something, it makes it very easy to make a mistake. And the really sucky things about these problems are there's so many little steps that you leave out a negative somewhere, the whole thing goes to shit. Right? And this is something you got to deal with these kind of problems. So to kill the Y, I could do 1 and 2. So that'll give me 3x plus 9z equals 0. That's kind of cool. So x plus 3z equals 0. That's equation 4. And then I could kill between these two. Just have to double this guy. So I can do twice 1 plus 3. Twice 1 would be 2x minus 2y plus 10z equals negative 4. So I get 3x plus 9z equals 0. I get the same equation, right? Funkadelic. So what happens here is, so here's my equation number 5 is x plus 3z equals 0. I can't really solve that, can I? So all I could really do is x must be negative 3z. Right, just to solve that, that's really all that tells me. But what can I do with that now?
Plug it in everywhere you see x.
Yeah, well, one place. I could plug it in maybe, it doesn't matter. This first guy, right? Let's see what we can do with this. So, like I told you earlier, this is a funky one. Oh no. So I got this. So now I can go back to maybe number 1. X minus y plus 5z, but x is negative 3z. You guys kind of with me still? Trying to get as much information as I can. So what actually happened here, behind the scenes here, they gave me 2 pieces of information and a third one that actually was a combination of the other 2. And I'll show you that here in a minute. The very little bit of time we have left. Well, let's finish this out real quick. Put these together, I get 2z minus y is negative 2. So I get y is 2z plus 2. Is that cool? So what does everything seem to depend on here then? Z. So you're going to love this. If you call z t, then what's x? Negative 3t. And what's y? Cool. That, incredibly enough, and I love the way that it introduces like it's brand new, but guess what that t is called? That is called the parameter. Well, duh, we just got out of chapter 8 where we talked about parametric equations. And t was the behind the scenes dude. He's the parameter of the problem. This is the parameter. Now we live in 3 dimensions here, x, y, z. How many true variables are there in this system of equations here? For the answer, how many true variables are there? 1. And if something has 1 true variable, it's going to be a line. It's going to be one-dimensional. It's going to be a line. So this is a line in 3-dimensional space. So what's really going on here is they've given me a plane and another plane, but the third plane wasn't really its own plane. It was like a combination of the 2 they already gave me. Are you guys cool with it? So I really just have 2 pieces of information. So did I get a single answer? No, I got actually an infinite number of answers, and those answers are the line where those 2 planes meet. So if I have this plane and that plane, I'll call that over there. If this plane and that plane, they meet at that line. So this is the equation for that line. That's kind of cool. If I get an answer, I might have 2 parameters. Oh shit, I might have an s and a t. Then that would be the equation of a plane. And so forth. Then you have 3 parameters, it's the equation of a cube, possibly. Or some other 3-dimensional shape. So real quick, last thing. I told you I'd look at this a different way. And there's no way in hell that right now you'd even tell to try this. But I just want to show you the possibilities. Just go with me for a second. If I were to do this negative 2, then would that be negative 2x minus y minus 4z equals negative 2? Right, just multiply 2 by a negative. Right? So let's just kind of eliminate that for a second. If I add all 3 of these together now, what do I get? I get x minus 2x plus x, 0. Negative y minus y plus 2y, 0. 5z minus 4z minus z, 0. Negative 2 minus 2 plus 4, 0 equals 0. So that, remember what that told you in just regular one equation when you get z equals 0? What does that mean? I love the way you said it. It should be all real numbers, but another way to say it is infinitely many solutions, and that's exactly what we got. Right? If I ever end up with 0 equals 0 somewhere, like we would have if we would have tried to do something with this, they would cancel each other out, right? That's trying to tell me I'm going to get infinitely many answers. I should need a t parameter at least to describe the answers. Yeah?
Could you ever reduce line 2 by dividing by 2?
I could, but then I introduce a fraction right there, yeah. Cool. All right, that's plenty. Yeah. Because whenever I try to solve something, if I solve this equation here, what that really means is when this is true, this is true. You with me? So if I get this, when this is true, this is true. This is true always. Right? 0 is always equal to 0. So in some way, this has to have an infinite number of answers. It has to reflect that it's always true somehow. Does that make sense? So if I got 0 equals 1, it says that's never true. They're parallel. They never intersect. You with me? Yeah. Cool.